அந்த குரூப்லயே அமைச்சிருக்காருங்க.
All right. Hello everyone. Welcome to our first live session for Maths for Electronics 1 course. I hope I am audible. Can somebody confirm?
Yes, yes.
Thanks. So so I'm really excited to get started. This session, since this is a very fast session, I would like to start in a very slow manner. Let's try to lay some foundation on why mathematics is really needed, and especially in electronics. And over this course, over this 12 weeks of the course, in which way you should think or proceed with respect to mathematics course, at least, like how do you solve a problem, how do you think logically, how do you analyze a concept, how do you understand the concept, and how do you apply it. And in order to gain good understanding on any topic of mathematics, good practice is required. Huge amount of practice is required. So definitely huge amount of time is required in order to excel in this particular course. Okay, so I am Srikanth Venkateshan, one of your course instructors in this particular term. Along with me, I have Sivakrishna also. He will also be the second course instructor. Sivakrishna, if you could introduce yourself, then we can start.
Hello everyone. Welcome to the new course. I'm Shiv Krishna Dasi and I'm currently doing postdoc. I finished my PhD. So welcome to this session, and I'm going to take the sessions from Sunday on Sunday. First session will be. Okay, thank you.
Yeah, thanks, Sivakrishna. So in Math for Electronics 1, in this particular term, we both were the course instructors. You can tag us in discussion forums or discourse. Anywhere you can tag us, ask your queries, or come to the live sessions. Any one of them will be taking the live sessions. You can clear your doubts. All right. So I would like to start with the live session details for Math for Electronics 1. Since this is the very first session, as I said, I will tell you what all we are going to do in these live sessions and when will this be conducted, and kind of administration kind of uh, things we will deal in the initial 15 minutes, and then we will start the actual session. Okay, so there will be 3 live sessions for each week. The first live session will be on Friday. For every week, if Friday we release the content, the next Friday will be your first live session of that particular week. Okay, so just like this week, right? So last Friday we released week 1. Today we are conducting the first live session for week 1 contents, and it will be for 1 hour, 10 to 11 in the morning. And then the second live session for that particular week will be conducted on Sunday from 8 to 10 p.m. It's not early morning, it's in the night. Similarly, live session 3 will be conducted on Tuesday, 8 to 10 p.m. And I will give a rough outline on what all we are going to do in each of the live sessions. So we'll not be doing the same thing. So in live session 1, we kind of summarize the whole week. Right, so we kind of deal or emphasize the important concepts that you have to definitely learn in that particular week, and we kind of do some problems related to those topics. In the second live session, if we were not able to finish this summarization in the first live session, then we will continue and finish the summarizing part, and we will solve. So it will be like summary plus solve or clear your doubts. Okay, so you might be having any doubts while you go through the contents or while you solve activity questions or practice assignment or graded assignment, whichever it is. Even if you are trying to follow some textbooks, and in that textbooks, if you have any doubts, you can clear your doubts in live session 2 as well as in live session 1 also. So this is always there. In any of the live sessions, you can come clear your doubts. But what we are going to do is we will also solve some problems, some difficult problems. So far, we have seen from your past seniors, they would have raised some concerns in activity questions or practice assignment or graded assignment, right? So those questions we will try to solve it and teach you how to solve them. So in live session 1 and 2, these are the things that are going to happen. But in live session 3, which will be taken by TA, and it is named as Solve with Us. So what does solve with us mean is you have to solve along with us. So within the 2 hours of time period, our TA will come up with some 10 or 12 problems related to that particular week. Let's say week 1. So on the next Tuesday, the TA will come up with 12 problems related to week 1 contents. Right? So the TA will show you the first question. You will solve it. You will be given some time. You will solve it and submit your answers. Then the TA will show you how to solve it in the best way possible, and then move on to the next question. So like this, the TA will solve all the 10 questions within that 8 to 10. And by attending that session, you will get to know how to solve any kind of problem of that particular week. And also it will help you to solve the graded assignment questions, because some of the questions will be just the replicas of your graded assignment question. And then you will get a good understanding on that particular week also. So if you solve more and more problems, you will get more and more clarity on the concept. Okay, so in the live session 3, we are going to do that. And yeah, so apart from these 3 live sessions, we are also going to do some revision sessions during the quiz weeks. Okay, so apart from these 3 live sessions which are dedicated to each week, before quiz 1, we will conduct 2 revision sessions, especially to revise the concepts that are very, very important for quiz 1. And you can talk to your seniors. So far, the feedback was if you attend the revision sessions, you can actually boost your quiz scores. Okay, so I strongly recommend you guys to join the revision sessions and follow us. And likewise, before quiz 2, before end term, we will conduct revision sessions also. And since I have said what all we are going to do in these live sessions, we are not going to address any of the administration kind of issues, because we are not the correct person to address it. If you have any administration issues, please support email to support es@study.iitm.ac.in. So you can raise your concern here, but I mean Shivakrishna or me, are not very sure or guaranteed that your thing will be sorted out. I might take your roll number, I might push it from my side, but it's always good that you sort it out on your own. Okay, so in these live sessions, mostly we'll focus on technical issues rather than administration kind of issues. All right, any doubts or anybody would like to speak up? No one? Or would you guys like to introduce yourselves or? Okay. Am I audible?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Thanks.
Yes, sir.
Okay, great. So what I again suggest is this. I usually suggest to my students, even earlier, my old students also. See, we taking live sessions is not a big deal. Okay, so now that we have enough experience, we can come, just say what we wanted to say and leave. But if we want to enjoy the live sessions, if you want to enjoy the live sessions, or me, like if I want to tell 100% of the things, if you don't interact with me, I might feel I might lose interest and I might cover just 50% and just leave. Right. So I strongly request all of you, at least few of you, to have a good interaction during the live session. So if you understood, please say yes, we understood. If you have any
So,
doubt, please
Yes,
raise
sir.
your hands,
yes,
ask the doubts. Okay. So in that way, it also feels me that I am not doing any monologuous uh, thing or anything of that sort, right? So let's not get bored during this live sessions. Let's entertain ourselves. So if you feel that we are doing too much of technical, if we want to take a break and discuss something else, I am very much open to it. We can have a discussion on any topic until and unless I know it. Right. So if I am unaware of the topic, I might skip, but you can have the discussion. And then after we get refreshed, we can come back and discuss the technical details. Okay. So please feel free to discuss. And if we interact, no, we will learn better. So you teach me, I teach you, and we will grow together.
yes, sir.
Okay.
Yes, sir.
So, all right. So let me just give you some outline of how this session is going to be. So we will discuss why study math in engineering and especially in the field of electronics. And then we'll also see how what do we mean by mathematical approach, right? So how do I solve a problem given any problem? What is the mathematical approach? And with some examples, of course. And then given an expression or equation, how do you visualize it? So these three things we'll do it today. And if time permits, I'll also start off with functions of one real variable, which is very easy for most of us because straight lines and quadratic functions, these concepts we have been studying it from our childhood, right? So if time permits, we will also see that. Okay,
Yes, sir.
great. So let's begin with a very simple question, but very important question, right? So why study mathematics at all, right? So now many of you might have wondered this before, right? Maybe in school you would have thought, why should I study this? Or even recently you started hating mathematics or started thinking, actually, why do I need to study mathematics, right? And most of us feel, even I used to feel in my childhood, that math is just about solving problems in a textbook, right? So that is what we think. So math is full of a textbook full of problems and we have to solve it. But in reality, math is actually helps us in many ways. It gives us skills and tools that we end up using everywhere, everywhere. So let me explain those. Firstly, it trains your brain to think step by step. Okay, so if you are learning math or solving mathematical problems, it will automatically train your brain to think step by step, like where to start, where to move, where to end, instead of just rushing to the answer. Right. So you learn how to break a big problem into smaller parts and you learn to follow a process. Right. So for example, let's say we are debugging a circuit, right? So if you are debugging a circuit, you just don't poke at random wires, right? So you won't go randomly pick one wire and poke. So you test one part, then another until you resolve the issue, right? So until you isolate the issue. isolate the component which has issues, right? So you don't randomly do it, right? So the same logic process comes from math, right? So basically it builds our problem solving skills. And secondly, math actually forms the foundation for science and technology, right? So you take physics, you take electronics, you take computer science, you take data analysis, you take any field in the engineering, all of them, literally all of them rests on mathematics. And if we didn't have equations to represent physics laws, we wouldn't be able to design circuits, predict outcomes, or even simulate systems. None of thing will happen. So my quote is so this quote I usually believe: math is not a subject. Math is the language in which science is written. Okay, so my way of looking math is, it's not just a subject or anything to me, it is a language to me. Just like you have English, Tamil, Telugu, Kannada, in the same way. So these languages are used to communicate, but this math is used to communicate with science and technology. Right. So that's how I see. And I hope at least some of you would start seeing it as a language from now. And yeah, so that's the second reason why you should study mathematics. And the third comes, maybe this is not important for our electronics course, but actually it matters. So math even improves something practically important in our daily life, right? So when you calculate simple interest or compound interest, or when you manage, yeah, any
Sir,
doubt?
sorry for
Yeah,
the disturbance. Actually,
yeah,
I am a maths teacher, sir.
yes,
I have seen many quotations.
yeah.
Maths is the important one, and maths is the king of the all sciences, like that.
Mm-hmm.
But
Mm-hmm.
this quotation is very much attractive to me, sir.
Oh, thanks. Thank you.
Yeah, yes,
That is much appreciated. Thanks.
yes.
All right. So let me get back. So as I said, it enhances financial literacy. Means in your daily life, right? Yeah, if you want to manage your budget, if you want to evaluate the cost versus the benefit. Now that Amazon offers are going to come, Amazon or Flipkart offers are going to come in. It came already, right? So when you want to evaluate this cost versus benefit, how much will it benefit me, right? So you will check how much percent of discount they are giving. Earlier, what was the cost? Now, what was the cost? If I buy it now, how much money I can save? So when you think of these things, all of this is math, right? So math is required. So if you don't know math, then you might end up buying a product which actually costs 1,000 rupees, but you pay 1,500 rupees or something like that, right? So that is another important reason why you should learn math. And fourth comes, it actually sharpens our analytical thinking. It trains you to recognize patterns, test whether an idea is correct, and think critically. Okay, so you so this is exactly what a scientist or engineer must do, right? You should test, check, validate. So this kind of thinking math develops. So math sharpens. It will not develop. So it will just sharpen it improves your analytical thinking also. And finally, this is very important, right? So we are studying because we should be in a good stage tomorrow, right? So finally, it actually opens up career opportunities. So few are good at math. Okay, so then you have many career opportunities. So if you look around at this fastest growing fields, right? So like data science, AI, robotics, electronics, machine learning, everywhere, every single one of these areas demands strong mathematics. So that is why we are studying mathematics as a basic course in the foundational level, right? So even in data science also, mathematics for data science is a foundational course. So this basics is very, very required, and you should strengthen this basics. And if you are good at this, then you can go into any of these fields, right? So finally, my statement is, it's not an optional skill that you have to develop. It's a gateway skill, right? So if you want to get into something, then this skill is definitely required. Okay. So now when somebody asks you, why do I need math? Here are the many, many, many reasons. There are many, many, many reasons. These are 5 reasons that I wanted to showcase. Right. So now you can answer this to your fellow mate saying, because it gives you the mindset, the tools and the opportunities to solve real world problems and build real world systems. That's as simple as that. All right. So I hope I have given some enough justification on why we need mathematics. And now my question to you all is, when you think specifically of electronics, where do you guys expect math will show up?
So in circuit solvings.
In circuit solving. Good. Anybody else?
Sir, whenever we need the answer, we have to go for approximation, sir.
Okay.
With the help of that skill in approximation, we get the answer quickly.
Okay. Any other answer?
Signals.
Signals. Good. Mechanics. Yeah.
Suppose if we are given any circuit,
Hmm.
first where we have to concentrate in this circuit, how to divide that circuit into simple parts.
Right. So all of you are true. So some of you have said circuits, some of you have said signals. Maybe somebody of you have already thought of this control engineering, mechanics, instruments, right? So, and you are all right, because math shows up in all of these places, just in different forms. Okay. So now let's move and let's try to I will try to expand this a bit. Okay, so now that we have answered the big question, right? So why study mathematics is important, we will narrow it down a bit. Why do we specifically need math in electronics, right? So here are the few set of places where you strongly need mathematics, right? And again, if I have to give a simple answer to this, electronics is simply written in the language of mathematics. Okay, so again, the same answer, I have said it in different way. Every circuit, every signal, every system, they can all be described using equations and functions. That's it. Right? So I will tell you now how that is. First and foremost reason is we will use math in circuit analysis and design. So think about Ohm's law, okay, right? So I hope everybody knows Ohm's law, right?
Yes, sir.
If not, then it is V is equals to IR. Right? So where V is voltage across
Two terminals.
And I is current passing in the circuit, and R is
The
Resistance of a
resistor. Correct. So this is the mathematical way of representing the circuit. So when you design a circuit, you don't just guess how much current will flow, right? Rather, we will calculate it. Right. So when you choose a resistor, capacitor, or inductor, You have to balance the equations to meet designed requirements, right? So without math, circuit design would purely be trial and error, right? So if you're not using equations, it will just be trial and error, right? Simply like if I say a resistor has resistance 10 ohms and the current through it is 2 amperes, then the voltage will not be 40 or 60, right? So it will just simply be 2 into 10, which is 20 volts, right? So that's math, right? So all the circuit analysis and designing a circuit involves mathematical equations. And secondly, math shows up in signal processing. And as we all know, signals are nothing but functions of time. So when you see, when you come to, maybe I think you would have started seeing signals in ESTC, right? So signals is represented as functions of time when you listen to a music on your phone, right? So that's a signal. When noise is removed from a recording, that's filtering, right? So all these things are done using mathematics and Fourier analysis, convolution, Laplace transforms. All these are mathematical tools to analyze signals, right? So that's the second reason why you need math in electronics. And the third comes on control systems, right? So I hope most of you have wondered this, right? So how an elevator stops exactly at the correct floor, or how drone maintains its balance, right? So that is actually the control theory. So that you are going to study in future. So the stability of these systems is determined by solving differential equations, right? So differential equations is, again, you have to know what a differential equation is and how to solve a differential equation, or even quadratic equations, higher order equations, everything comes there. So once you solve that, or once you analyze those equations, then you'll get to know how the system will behave. So whether the system behaves actually how we predicted, or will it go unstable, right? So in order to know this, you should know math. And the fourth, and again another sub branch of electronics, which is digital and logic design, right? So math is literally everywhere in this small field. At our first glance, it might look like these logic gates are very easy, right? So and, or, not, or, so all these things are very easy to understand, but behind them actually lies this Boolean algebra, right? So which is a huge branch in mathematics, right? So when you design this adders, multiplexers, memory systems, right? So all these places you need this Boolean algebra, and if you want to know Boolean algebra, you should know this. You should understand that it is a small branch of mathematics and math testing, right? So these are four main reasons that I thought of, and I think Prof also has emphasized this a bit in the lectures. Please take a look at it. And yeah, so finally, math is not separate with electronics. Math is actually with electronics. Math is just a tool that allows us to describe, analyze, and design electronic systems. Okay, so therefore, the conclusion is this course is not just to get good scores and pass the course. This course is put in foundation level to build decent skills in mathematics, and therefore I suggest you guys to not to run behind marks, or rather run behind the concept or learning the concepts. So I can tell you, if you run behind learning concepts, automatically you can gain marks. But if you just run behind getting marks, scoring good marks, after a few months, so maybe this 3 months you might remember the concepts, but after you finish math 1 and go to next level courses, then you will forget what you have learned here. Okay, and you will again have to redo it or relearn it again along with the concept that you are learning there. So yeah, so that is why please learn in these 3 months and automatically you will get a decent score. So even a B grade or A grade is decent grades. Don't just run behind S grade. Okay, so aim for S grade, but even if you are unable to get S grade, A and B are also good along with concept learning. Okay, so yeah, so with that, the second part is also, I would like to wrap this up and we'll move to the next part. Any doubts, any clarifications, any clarity missing?
No, sir.
No, sir.
No?
No.
Okay, great. So now let's move to the third part of this live session. So far we have talked about why math is important. Now let's talk about how math helps us actually solve problems. Okay. So when we face a real world problem, what do? We kind of just stare at it, right? But actually we don't just stare at it. We hope the answers pop up in our mind, right? Or head, right? So mathematics gives us a structured approach, right? Almost like a recipe, right? So if you want to cook some nice dish, right? So you have to follow a procedure, right? So you just have to pour oil. If you are making a chicken curry, you have to pour oil first, then onions, mirchi, or other things comes in, then comes chicken, then comes the other masala parts, right? So you won't directly put chicken first, then masala parts, and at last oil, right? So just like the same way, mathematics also has a structured way of approaching a problem, right? Among them, there are few generalized steps that every problem follows. And here are they. These are the key steps that you have to follow when you are solving any kind of problem. Firstly, you have to identify the numerical quantities. Right? So what does it mean? First, we need to be very clear about what numbers or measurements are involved in the problem. Right? Something like, are we talking about distance? Are we talking about cost? Are we talking about current? Are we talking about voltage? Right? So we should know what the numerical quantities are given in the problem. Right? So, and knowing what information we have should always be your starting point. So given the information to you, you should know what all information that is important or what all information that is given. That should be our starting point. And then you assign variables to the unknown. Right? So what after first step, next what we should ask is, what do we want to find out? Right? So that should be the next question. So given this much of information to me, okay, information is given to me, what should I find out? Right? So once you know what you should find out, if there are any missing information, we give some unknown symbols to those missing information. So along with what do we have to find out? So usually what do we have to find out will be some variable. So you have to assign some variable to it. Usually we use X, Y, Z, right? So there is a fun saying, right? So math is just finding your X, right? So it came from this variables X. So we assign variables to the unknown information and to what do we have to find out. This makes it very, very easier for us to work with equations. Instead of words, all we have to do is give some variables to the missing information. Some information is already known to us. Like we have the numerical quantities with us. Now we have the variables with us. The next thing that we are going to do is establish a relationships using these variables. So for establishing this relationship, we use these formulas, laws, conditions, everything that we know comes here, right? So we write down how the known and unknown quantities are connected, right? So something like just now I said, right? It's like, it may be like Ohm's law, right? So Ohm's law, V is equals to IR. There you might be given voltage, you might be given current, but you might we might ask you to find the resistance. So R is unknown to us, I and V are known to us, right? So V is equals to IR came from the already existing relationship among the voltage, current, and the resistance, right? So, or maybe it's a budget equation, or maybe it's a geometric relationship, something like that, right? So, using those formulas, laws, and conditions that are given to you, we form equations. Once you form the equations, finally, we solve the equations. We form the equations and we derive the equations and solve the equations, right? So, the whole idea is identify, assign, relate, and then solve. So there are 4 generalized steps, and this is the mathematical approach. Right. So we'll see some examples and how this step 1, step 2, step 3, step 4 is following one after the other. Okay, so let's take this shopping and linear relationships example. And let's see how this works with simple story, small story, right? So suppose a shopkeeper has 1,000 rupees to spend and wants to buy a total of 5 kg of fruits, right? Maybe especially apples and oranges. And apples cost rupees 250 per kg and oranges cost rupees 125 per kg. Now the question is, how many kilograms of each fruit can the shopper buy? Sorry, not shopkeeper, shopper buy. Right, so simple question, and this is usually it's a real life situation, right? So when we go to any supermarket, we don't just buy one product and just come back, right? So we kind of want to buy multiple products, but we do have some budget constraints, right? So it may depend on many scenario situations, but there will be budget constraints and there will be desires or interests that we wanted to buy, and we have to balance both, right? So now let's try to solve this particular example step by step. Okay, so step 1 is identify quantities, right? So what all quantities that are available here? So we have cost per kg, so this is one quantity, right? And this also cost per kg, this is one quantity, and we have 5 kgs that need to be buy, right? So total weight that I have to buy, and there is a budget, right? So there are 3 things. One is just rupees, one is just in kgs, one is rupees per kg, right? So these are the 3 quantities that I can see. Am I right? Or are you guys seeing anything more?
No, sir.
No? Okay. So now this is step 1. Step 2 is assign variables to the unknowns. So what are the unknowns here?
How many kilograms of
We'll
each?
get
Yes, very good. So unknown variables are how many kilograms, how many kgs of
apple and
oranges,
Orange,
we can buy.
how many kgs of
apples.
apples, right? So these are the two unknowns. As I said, we will just assign them some variables, right? So let's say oranges I give some y, apples I give x. So you can interchange also. So it is just assigning variables. That's it. So you can give a, b also. There is no sacred of using x and y. Okay, so any unknown variables. Okay, so let's say x. Now what is x? X represents number of
No,
kgs
of
Number of
apples we
kg
can
of
buy.
apple
apples by we can
bought.
buy, right? So we can buy, and y is the number of
Number of
kgs
kilograms of
oranges
oranges we can buy.
we can buy. Right. All right. Step 2 is also done. Now we will move to step 3. Step 3 is basically to establish relationships from the given information or the standard known formulas we have. So here we don't have any formulas directly, but we can establish relationships. What relationships we can establish from the information?
So x plus y is equals to 5.
5.
Correct. So total I have to buy 5 kgs. And if apples are x kgs and oranges are y kgs, if I total these two, that should be equals to 5 kg,
5.
which is we say total weight equation. So total weight equation, if I write it in variables, it is x plus y, and the given information says the total should be 5. So these two should be equal. This is one equation. Can I establish any other equations?
Yes, sir.
Uh,
Sir,
hmm,
sir, the sum of the prices of both should be equal to 1000.
correct. So the next is total budget or the total cost I spent, right? So total cost that I can spend is 1000 rupees only. I cannot spend more than 1000. But since I am buying X kgs of apple and I know apples cost 250 per kg,
250 into x.
total cost I spend for apples alone will be 250x,
250x
right?
plus
And not
100.
only that, I am buying y kgs of oranges also, and each kg costs 125
125.
rupees. So that means if I am buying y kgs of oranges, it is 125
125y.
Y.
into y rupees. So this is for apples, and this is for oranges that I am going to spend. And the total should not cross 1000 or should not be less than 1000. It should be equal
1000.
to 1000.
Equals to 1000.
Now I have two equations with two variables. And if I know how to solve these two equations, two variable, which is system of linear equations that you are going to study in the next week. But since these are very small equations, we can easily solve it, right? But at least
Yes, sir.
you should get to step 3 in week 1, right? So you should know how to get to step 3. But from here, if you don't know the concepts of solving system of linear equations, then just uh, wait for one more week. We will do it in the next week. But what you can do is, once you know how to visualize these two straight lines, you can plot it in some visualizing
Graph.
tools, which is graphical tools like Desmos is a nice platform where you can plot any kind of equation. You just have to plug in the equation, it will give you the graph. And if you know how to do it, then you will just plot these two things, and wherever these two curves intersect, that is our required point, right? So that is for problem 1. And the next one is forming example, which actually connects the quadratic equations. Okay, so suppose we say a farmer has 100 meters of fencing to make a rectangular field. Okay, so the farmer wants to construct a rectangular fencing around his field. Okay, and he has 100 meters of fencing, so that means he can only, so this is the fencing, and he has to fence in all 4 directions. Right, so the total fencing, we have only 100 meters, and he might have certain restrictions, like he wants the length of the field to be some 10 meters more than its width, right? So something like that. So the length, so this is length, and this is width or breadth. Okay, so what he wants is, he wants this length to be 10 meters more than the width. Okay, so width is not known to us, length is not known to us, so that means we have to assign some
Variables.
variables. So if you assign width to be x, then length would be
X plus 10.
x plus 10, right? So we have this, and also we have, so this whole thing is called, so if I add 2 lengths and 2 widths, what is it called for a rectangle?
Perimeter.
Perimeter, right? Good. So the total perimeter is given to me, which is 100 meters, right? And also the length is width plus 10 meters, right? And we have also assigned the variables, width to be x, and the length will become x plus 10. Now the third step is to establish a relationship. So can we establish a relationship here?
Yes, sir.
Yes, sir.
2x plus 2 into x plus 10 is equal to 100.
100, correct. So 2x, so which is sum of the 2 widths plus sum of the 2 lengths, which is the perimeter. The total perimeter should be 100 meters, right? So
Yes.
that's how it is. Now it is like 2x plus 2x plus 20 is equals to 100.
100.
And
4x
4x
plus
is equals to 80, x is equals to 20.
20.
Right? So once x is 20, length will be
30.
30. So width and length we got, if it is perimeter. Right? So now instead of perimeter, if we have given you area, right? So the same thing, instead of perimeter, if I say, okay, I'll not erase this. Maybe here I'll write. Instead of perimeter, the same thing. So the length is 10 greater than the width, but the information that is changed is total area is 100 meters square. Okay. So the change will come when we establish the relationship. Right. So step 3 will change. How will it change? Total
So it will
area.
be
What is the total area?
100
Length into
meters square.
breadth.
100 meters square. If I have to write total area in terms of length and breadth, what is total area with, is there
X
any
into
connection?
10 plus X.
Right. So length into breadth is the area. Right. So length we said it is X plus 10. Breadth we said it is X or width, which is 100. And 100 is equals to X square plus 10X. And we'll get X square plus 10X minus 100 is equal to 0, which forms a,
Quadratic.
this
Quadratic.
is a quadratic equation. Right. So this also we'll see in the next lecture maybe. So like this, given some information, any real world information or any kind of information, there is a structured way of solving that particular problem. Right. So identify, assign the variables for unknowns, then establish the relationships, then derive them and solve them. Okay. So yeah. So what are these expressions and equations, right? So that's the next question. So I have said this previously also. So math is all about expressions and equations, and especially in electronics also. So an expression, it is a mathematical phrase that contains numbers, variables, and operations like addition, subtraction, multiple, or division, but does not have an equal sign, right? So something like 3x plus 2. So 3x plus 2 is an expression. It's not an equation. Okay, so there is a subtle difference between expression and equation. Expressions are just a mathematical phrase. Okay, so something like this, 3x plus 2 is a expression, whereas equation contains an equal to sign. So a mathematical statement that shows two expressions are equal using an equal sign. Okay, so usually these relationships are expressed in equations. Right, so voltage is equals to current into resistance, or distance is equals to speed into time, or etc. So this was also very well explained in the lectures. I suggest you guys go back and see the lectures. Okay, so the next thing is, how do I visualize expressions and equations, right? So what you have to do is you have to consider an expression, let's say 2x, and then just think, how does this 2x related to x? Okay, and 2x and x has the same variables. So what we do is we assign a variable to 2x, let's say y. Then it will become y is equals to 2x. Now once you have y is equals to 2x, then all you have to do is plot y versus x on the Cartesian plane, xy plane. Right, so this Cartesian plane is a plane that contains two axes, and the center is called origin, and one axis is horizontal axis or called x-axis, and the other is vertical axis, which is called y-axis, and these two axes are perpendicular to each other, so there will be a 90-degree, and the intersection point of these two axes is called origin, and that is the center of this Cartesian product. And there will be four quadrants. So these four open spaces are called four quadrants. This is called the first quadrant. This is second, this is third, and this is fourth. And any point on any of the quadrants is represented by
X comma Y.
a pair x comma y, where x represents how far on x-axis if I project this point onto this x-axis, how far is it from origin? So in other words, the distance from origin to the point that is perpendicularly below to that x comma y point. So this is x, and similarly y is the distance from origin on the y-axis. So if I project this xy point onto this y-axis, then the distance from the origin to that point is what the second point represent. This is xy, right? So any point on this Cartesian plane is represented as a pair x comma y, where x represents this and y represents this. Okay, so now if I have to plot this y is equals to 2x, then it would be, we have to take one x value and multiply it with the 2, then that will become the y value. Then you plot x comma y. So if I take x to be 0, then 2 times 0 will be 0. Y will also be 0. So therefore, 0 comma 0 will be on the plot. Similarly, if I choose 1 for x value, then 2 times 1 will be 2. So 1 comma 2 should be included in the plot. So like this, if I put 2 for x, then it will become 4 for y. Then 2 comma 4 should be in the plot. Then 3, if I give 3 for x, then y will become 6. Not only integers, we can also give 2.5, 2.1, minus 1, minus 2, minus 3.2. So if I identify all those points and plot them, plot every single point of this by taking all possible values of x from minus infinite to plus infinite, then it will form a straight line that passes through the origin actually here. Okay. Okay, so it will form a straight line. So y is equals to 2x is a straight line if you plot it. So something like this. Okay. So yeah. So with that, I would like to end it here because it's already 11. I don't want to take a single minute extra. So this is the very first session, and the next Sunday will be the second session, and we will meet you on Sunday then at 8 p.m. Okay, so please look into the calendars and join.
Yes, sir.
Okay, so thanks all for joining, and we will have a great journey ahead. So I hope all of your participation during this journey. Thanks all and have a great day. Bye.
Thank you, sir.
Thank you.
Thank you,
Thank you,
sir.
sir.
Thanks.
Thank you.
Yeah, slides I will upload. Don't worry.